Hi everyone, I'm Emanuele Albini, and this is a joint work with Jason, Danial, and Daniele, all of us at JP Morgan AI Research. And as the title suggests, this work fits into the line of research that is trying to unify, on one side, feature importance explanations, and in particular sharp explanations, and on the other side, counterfactual explanations. So let's first try to understand why do we even want to do that. And let's take a look to the classic explainability setting in which we have a machine learning model, and this model rejects a client loan application because it predicts that it has a probability of default that is very high. So if we generate the sharp explanation for this client, what it will be telling us is how much each of the input features contributed to increasing or decreasing the probability of default of this client. But what it will not be telling us is which features and how should we change these features in order to change the rejection into an acceptance. And precisely for this reason, in the actionable recourse literature, counterfactual explanations have been proposed as a solution to this problem. And they provide suggestions on input features to change and how to change them in order to go from a rejection to an acceptance. But also counterfactual explanations have some limitations, and in particular there is no consensus in the literature on how to summarize multiple counterfactual explanations that we have to give to clients. And what we propose instead is to generate still a feature importance explanation that is very easy to understand and very compact, but with more counterfactual flavor, and that is really suggesting to clients what features to change in order to go from a rejection to an acceptance. And to achieve that, our core proposal starts from the understanding that sharp explanations are really contrastive explanations. And this is the case because, as it has been highlighted in the literature, when we are generating a sharp explanations, we must not only provide a query instance X, but also a background distribution of points. So the answer that we will be getting from sharp explanation is really what features are most important for rejecting client X when comparing this client X to a background distribution of points. And what this background distribution of points typically is the training set. And if we do that, we are basically comparing client X with a lot of other clients, accepted or rejected, that can be very different from X. What we instead propose is to use similar clients, but lying on the other side of the decision boundary, so being accepted, as background distribution of points. And note that this is exactly the definition of counterfactuals. Similar points to the query instance on the other side of the decision boundary. And what happens if you do that is that the explanation that you get from SHAP is much more useful to understand what features are useful to be changed in order to go from a rejection to an acceptance. And in our paper, we also propose a new metric to evaluate any feature importance explanations on how good they are in providing features that are really useful when we are trying to go from one side to the other side of the decision boundary. And this is a quantitative metric that we call counterfactuability. And what we show in our paper is that our explanations, counterfactual sharp explanations, perform much better than existing baseline in the literature along this metric. If you have any question, please contact me at my email address that is shown there, or please feel free to read the paper if you are interested in more details.